Okay, let's look at the definition of absolute maximum and absolute minimum. All right, so here's the definition. F of c is called the absolute maximum value of f if f of c is always greater than or equal to f of x for all x in the domain of f. So it's basically, it's a global champion. It's the largest value in the domain of that function, right? And the absolute minimum is defined similarly. So f of c is absolute minimum value of f if f of c is less than or equal to f of x for all x in the domain of f. Right? So that's the smallest value of the function in that interval. Right? So let's look at this picture. Right? So the largest or highest point of the graph is going to be obviously right here. Right? So this guy is the absolute max. Right? That's the absolute maximum. And I look for the lowest place, looks like here. Right? So that's the lowest place. So this is called the absolute minimum. Right? And notice that where absolute maximum and absolute minimum occurs, right? You can see that you have a sharp corner here, so the derivative does not exist here, which means that maybe I should note that so derivative there, f prime does not exist. Let's see, does not exist, which means that this is at the critical number, right? It's a critical value, right? And also the absolute minimum actually occurs at the endpoint. So this is the endpoints of the interval, right? So if you have absolute maximum and absolute minimum, chances are it's going to be at the critical value or the endpoints, one of the endpoints, all right? And another theorem, a good theorem about absolute max and absolute min is called the extreme value theorem, right? If a function is continuous on a closed interval from a to b, right? So it's nice and conditional, no breakage in the picture, right? Then f would have both absolute maximum and absolute minimum, right? So if you have a continuous function on the closed interval, then we can always find absolute maximum and absolute minimum, right? So the function being continuous is actually quite important on a closed interval, right? For example, if you have a graph which looks like this, right? Say you have a graph and say A is right here. Right, let's say it's not defined at A because it has a vertical asymptote. Right, say B is over here. Right, let's say the graph might look like this. You have a vertical asymptote and it's perfectly okay there. Alright, so you can see that in this graph, this function f would have the absolute minimum, which is right here, right? Absolute minimum. However, since this guy shoots up to positive infinity, which means that there is no absolute maximum, right? So the reason why this extreme value theorem does not apply to this graph is that this is only continuous on a half open interval, half closed interval, because A is not included there. So it's important to have a closed interval. All right, that's that. Right, I hope that this was clear.